Alright, welcome back to the 3D Sapiens Road Show. I'm Dan Davis. This is going to be the first episode on the math program here on the 3D Sapiens Road Show. And being filmed here in what I call the nest, the place where you're at when you're not on the road, whether it's a hotel room or a room you're renting or your house or condo or whatever it is. So I'm shooting a bunch of video today, and one of the things I wanted to talk about was the math and why I find it useful. And I'm not talking about, doing algebra problems for fun. No, I'm talking about the practical applications of math, the fun stuff. Like the music I do. Music is a perfect example of piecewise defined functions. Where you break down a song into the keys, basically. But I wanted to show you something real quick with the pictures, and aside from the little bit of humor here. Alright, so let me show you real quick a couple of these pictures in particular. This one here, if you were one of my math students, you've seen this actually posted in the class. That s equals 16t squared, that is the equation for freefall in a vacuum, which is pretty close for the first few seconds anyway. But this was a canopy transfer that I did where the main parachute was coming out, or was out just fine. Once it was out fine, then I pulled the reserve. You see it coming out. Once I saw that it was coming out fine, then I cut away the main. And you can kind of see the parabola here as you're falling. I kind of like that too. And then the reserve opened up, and I landed that. So skydiving, there's a whole bunch of, talk about glide slope. Like if you've got a canopy that has a 3-to-1 glide ratio, it's like a slope of 3, right? You go 3 horizontal for every 1 vertical you go down. There's a whole bunch of different applications. Also, for example, in freefall, controlling your speed is a matter of how big your body is. If you're jumping with people that weigh less, you need to kind of float, so you jump big, you spread your arms and legs out wide, and so on. And so there's this whole ratio of surface area to speed. But that equation right there, I actually used it base jumping. The first place I went base jumping was Auburn Bridge. These pictures right here are from my first jump. And you can see that I threw the pilot chute out immediately because I was just in the middle of a rush and I couldn't even think straight. After that, I started yelling out loud because otherwise, in a rush, you just can't think very well. But as I got more familiar with the bridge and with the base jumping and the rush and everything, and I did more jumps, I got up 10 or 11 jumps off of that bridge. And I got to the point where I kind of needed to know, how many seconds can I take and still have time to open up the canopy and get it set up for landing. And so I actually had to use that s equals 16t squared equation to figure out, and it comes out to about 5 seconds. But some other kind of extreme sport kind of things. Scuba diving, nowadays of course they got the dive computers, but back in the old days when I learned, they had pieces of paper that you actually had to go through the dive tables and figure out, and it's very algebraic. Let's see, bungee jumping. Perfect example of exponential equations. Hang gliding, that's just like skydiving, talking about slope, talking about all kinds of things. Rappelling, we could talk about the tension that's on the line, depending on how you tie up, and so on and so forth. Skiing, we could talk about coefficient of friction and how fast you're going to go. Like there's the music again, more bungee jumping in Thailand. Rattlesnake, I don't know, don't get bit by a rattlesnake. That's all I can tell you. Parasailing, again, more flight things, riding horses or motorcycles or whatever. You could, talking about velocities and distances and all that kind of stuff. So, actually, one of the books I'm working on, but it's way down on the priority list, like about 10 on the priority list, is a book, two different math books. But one of them is going to be this kind of stuff, where it's the fun math, reasons you want to know this stuff. Base jumping, for example. Here's another really good example off of an antenna. If you don't know the antenna, how high it is, you got to figure out how high it is. And you can use either trigonometry or similar triangles, where basically you know, you're standing over here and you look at the same angle and then you do a proportion thing. If you're this high, then this is going to be how high. Anyway, so there's all kinds of math, and it's really helped me. I mean, if you look at any group that I went through training with, skydivers or scuba divers or whatever, I was usually the first to learn because I saw the mathematical applications. And then getting into traveling and whatnot, of course, changing money, currency, so you don't get ripped off, that kind of stuff, and so on. So, there's a lot of good stuff about math that doesn't involve just, like I said, sitting around doing equations and whatnot. So I hope you tune in, and I hope that mathematical education here in the United States gets better, because as a former teacher, I can tell you what we're allowed to do, what we have to do, is just tragic. Anyway, thanks for tuning in, and hope we'll see you again.